equals mass times acceleration. The mass is this and this because it's the whole system. So 2,500, and the acceleration is 0.5. So times 0.5 equals 1250 newtons. The tension between the two systems here, we take only this trailer, which is 2000. We find the F net of that, which is mass times acceleration. Since there's no resistance, so we don't need to take that into consideration. So then the mass of the trailer is 2000 and the acceleration is 0.5. So then the tension equals 1000 newtons. How far does the tractor move in the first 5 seconds? So we use SUVAT equals UT plus half AT squared. The initial velocity is 0. So that cancels out. And then S equals acceleration is 0.5. It's given up top. And that should be 0.5 times 25. 6.25 meters. The radius is 20, the constant speed is 15, the mass of the bike is 300. Find the magnitude of the net force. So this is centripetal motion. So F net equals mv squared over r. The mass is 300 times the velocity, 15 squared. Radius is 20, and that should equal 3. Only has 2 forces on the bike and the rider. Draw an arrow to show the direction of the F net force of the bike and the rider. So the normal force is perpendicular and the weight force is down. So then the centripetal motion is towards the center, which is here. And if you look on the diagram here, it's going to be this way. Explain how the forces shown cause the net force. I use the triangle to represent the forces. This is down. This is the F net towards the side. Because the normal force is towards top and then F net is towards the side. Mg is down, so the direction is the same. The angle is on the top. So then I said according to this, to the diagram, the weight force and this is perpendicular because from the top normal force is perpendicular to the surface here is So then to find the angular, I just use the angular triangular forces. So I did tan theta equals F net over FG, and F net equals ME squared over RFG equals MG. So therefore tan theta V squared over RG theta equals tan inverse V is 15 meters per second, 15 squared, radius is 20, so theta equals 48. The mass of A is 0.05, 0.10, and 20 kilograms. What is the force by C? 1 to B. So the normal force from there. So the normal force that exerts from C to B is the weight force of these two together that comes down. The normal force stops the two weight force of A and B from going through down. So then mg m1 plus m2, this is m1, m2, m3, g equals fn f1 times 10, normal force equals 1.5 newtons. So for the explanation, this is according to Newton's third law. So according to motion, the force exerted the weight force from object equal to normal force exerted from object C. The table is now removed and the block is free to fall. Since there's nothing stopping it from falling, there's no normal force. So then that's 0. The explanation was this surface minimum speed traveling vertical with a radius of 15. The minimum speed. So when it's at minimum speed, F net equals At minimum speed, Fnet equals 0. So then mv squared over r equals mg. V equals root rg. V equals root radius is 15 times 10. So then that should be 15 root equals 12.25 meters per second. Millennium has a mass of 60 kilograms. At point A, when it's traveling at minimum speed, at point A. So when she's traveling at point A, Fn is down, and so is the weight force. So then there's no normal force exerting onto her, so then she feels apparent weightlessness. And we can prove it by just subbing the values in. Net G, Fnet is mv squared over G. Velocity is 12.25. But we have to use the original value, otherwise it won't equal 0. And that should equal 0 if you use the original value instead of 12.25. The reason was that F norm force equals 0. Therefore, weightlessness. Now, as it passes point B, the velocity equals 5.5. So at point B, person feels more normal force than weight force. That's why they feel more heavier. So then Fnet equals normal force minus the weight force. Then normal force equals mv squared over r. Then normal force equals the velocity is 5.5 over 15. And I got a value of 721 meters. Leaves the barrel with a velocity. So that's the initial velocity. Travels at an angle of 37. There's no air resistance. So we need to find the time it travels from A to B. So we know that this distance, using SUVAT plus AT, the vertical component, the final velocity is 0 at this point. The initial velocity using the vertical component is 24 sine 37 minus 10t. Then we get 10t equals 24. we get 2.9 seconds. What is the maximum height of the trajectory? Using the vertical component again, we know that at maximum height, the velocity is 0. So then v squared equals u squared minus 2as. That's 0. Initial velocity is 24 sine 37. That's a s, not a 5. So therefore, 10 meters. Next question. Fred is sliding down slow. Fred is a mass of 60. It's traveling from A to B. There's a vertical height of 12.8. And there's no friction. What is this momentum? So P equals mv. The mass is 60 times 16. At point C, he runs into grass. So there's constant friction now after a time of 6 seconds. What is the magnitude of friction as he travels from point C to D? So now he's traveling from here to here, and there's, so the only force is F net. So F R equals ma. We don't know a, we need to find a. So we've been given that t equals 6. So then using a suvat, the final velocity, that's when it stops, is going to be 0. The initial velocity is 16 minus 10t. No, not 10t. 6a, t equals 6, yeah. So then, if we find what a is, acceleration equals to 8/3, and then we plug it into here. Mass is 60 kilograms. So then 60 times 8/3 equals 60 newtons. Suspended ignore mass. So in here there's always weight force because it's vertically down. And without the mass attached, there's an unstretched and 40. And the mass is at 1 kilogram. When the mass is 1 kilogram, the mass is stationary. It's a length of 70. So when it's here and when it's here, this should be the change in x. When the spring is stretched, so then Fg equals the strain energy. So then Mg equals K, change in x. M 1 kilogram, so 1 times 10. And the change in x is from 70 to 40, but this is in centimeters. We need to convert it to meters always. So 0.3. K should equal 33 Newton per meters. Okay, the spring graphs. Which graphs? The kinetic energy. So kinetic energy has a formula of half mv squared. So then this should be a parabolic. So then if we look on the graphs, which one is parabolic, we have this option and this option. But we know once it's let go, that the kinetic and the strain energy is converted to kinetic energy, so it increases. So then it should be D. The total energy, with the total energy, it's always constant. It's always going to be a straight line, unless it's inelastic, but this should correlate with C. It's always going to be constant. Energy is not lost or gained. The gravitational formula is mgh. I kind of just use the formulas because it just tells me what kind of graph it's going to look like. So this is just going to be a linear. And if we look at the linear lines, we have, it can't be this one because it can't be constant. It's either this, or this. But we know that the gravitational energy is decreasing because kinetic energy, whilst kinetic energy increases, gravitational energy decreases. So it can't be this. It has to be this one. This one is increasing as well. So it can't be this. This is the strain potential energy. So this is F equals K A X squared. Again, this is parabolic. So then this correlates with option F because it does not plateau. This plateaus at the top. I just referenced this formula for my explanation, so I just said according to formula as increases. E G. Parabolic shape. You don't need to include the last part. So assume that somewhere in the space there's a spherical planet with a radius of 30. By some chance, this person who visits Earth, he finds the ways, even though Earth is much larger. So the Earth radius is that, the mass is this. Whoops. mass is this. The gravitational is this. So we're supposed to calculate the value of gravitational field of the surface of the visitor's planet. We use the formula G equals G over R squared. So we're subbing G, which is 6.67. The mass is the center mass, which is 5.98. Radius is the Earth's radius, this one. Square that, and we should get, I got 9.8 Newton per kilograms. What is the mass of the visitor's planet? Explain your answer by show. So this one is just going to be, we're just going to equate the gravitational forces. So then wait, no. For this one, the G is the same. We're trying to find the mass. So then G, we use the same formula, G M over R squared. The G is the same as Earth, which is this. So then 9.8 equals 6.67 times 10 to the power 11 times M over the radius, which is the radius of this small planet, which is 30 kilometers. We need to convert that to meters. And we should get 9.8. $1.3. Three times 10 to the power 20. This is the one where we equate the gravitational forces. So G, M1, M2. These M's are the same. So then V equals 2 pi R over T. Sub that into here. The G M1. 4 pi squared R squared over T squared times R. We should get that. Then we need to find the period, which is this. So just times it across. So then T equals root. The mass of the center, which is 5.7 times 10 to the power 24. So then the period equals 10 to the power 6 seconds. Next question. Oh, that's not the part. Okay, Einstein's theories. Each proton is that. So that's the energy. Proton mass is equal to this. So with this one, I just used the conservation of energy. M1 plus M2 because they combined into one. So then M1C squared. We know this energy, one of these energies is here. So we can just sub that in. And then just divide by the speed of light. This cancels out. And this mass is given here, which is 1.6726 times 10 to the power negative 27, which should give you option B. Question 2. The amount of energy requires to increase the speed from this to this. Why much more energy is required to produce the same change in speed? The rest mass is not constant but dependent, yet does not depend on velocity. So that's wrong. So it is more massive at high. This is definitely wrong. The more energy required to increase, because this is a parabolic equation. This is definitely in the last part, part D. If you change this formula, so if you change it by just decimals, as you approach C, it significantly changes. So this option makes the most sense. Has a speed of this. Just if you're wondering where the speed comes in, this is the speed from this value. That's where you get the speed from. The work done is change in energy. So the change in energy is this. So the bigger one is this one, so I'll just put that first. Shouldn't really make a difference, but we'll just get a negative value. Mass, you can take this out, which will give you this value, the energy. So then you'll get 1 minus 2 mc squared 1.1 minus 1.05 times 1.10 to the power negative 10, which is 7.5 times 10 to the power negative 12, which is this option. A tower is 100 meters tall, traveling perpendicular to the ground as it passed the top of the thing. Speed of the cosmic ray. So we have the two lengths. The tower was 200. So then using the formula L equals L length over this 300 equals 200. So then 200 equals 300 because this equals to 1 over c squared root 1 minus v squared over c squared. So then you should get 200 over 300, which is just 2 over 3. 2 over 3 equals, square this, equals 1 minus v squared over c squared. So therefore you should get v over c equals root 5 over 9, which is equal to 0.75, which is this one. In deep space, a process B with a relative speed of 0.5 c. Each spaceship sends a radio message, same distance from each spaceship. Which of the following statements above is correct? Both signals will arrive at the same time. Yep. Because according to Einstein's postulate, speed of light is constant. So then, in any frame of reference, it would be the same thing. It can't be this because it's constant and this is constant, so it can't be any of the rest. Two cars traveling the same speed are approaching a country motel opposite directions. In figure 1 below, they are equidistant from the motel at the same time and simultaneously sound the horns to indicate. Since the strong winds is going this way, the vehicle is going in the same direction. Therefore, the sound will travel faster if it's going the same direction than if it's going in the opposite direction, because this car is going in this direction, but the wind is going in this direction. The medium, it's the speed of the signal is dependent on the medium. So A makes the most sense. Question 7. The speed of Earth through space. I don't think that's right. It doesn't, because it's got to do with light. Change of speed, nope. Accuracy, nope. Differences in, yeah, it's got to do with the speed of light. So the rest of the options do not make sense and don't really relate to this. Question 8. Scientists are planning an experiment that must be created in an inertial frame of reference. They choose a location in deep space, far from the gravitational field of any star or planet. Which of the following best option for them to choose? Slowly rotating. That's not an inertial frame of reference. A does not equal 0, so then it can't be A. It's hurtling through space. Okay. And gradually slowing down, so A can't equal 0, so then for an inertial frame, acceleration has to equal 0. Or traveling at a constant. In a very slowly moving acceleration that is gaining speed. So that's out, because that's not an inertial frame of reference. So it's B. Scientists observed a path that 5.4 millimeters long. Scientists measured the speed as that, given that what is the proper lifetime? So the formula for that equals T O. And we're finding this, the T over TO. We don't know the time, but we have the length and speed. So just using the V. Distance over velocity. 5.4 times 10 to the power negative 3, because we need to convert it to meters always, because it's standard units. Velocity is that. So then T should equal -11, and if you sub that into here and sub this into here, T0 should equal 1.2 times 10 to the power -11, which is option D. Which of the following best explains why it's impossible to accelerate particles such that it's traveling at the speed of light? Is what? It is directly forbidden. This is not a really good explanation as to why that happens. As particles increase in speed, the rest tends towards an infinite value. The kinetic energy tends towards an infinite value. This option makes the most sense because the other options don't actually tend towards infinity. Which of the following statements about proper length is most accurate? According to this formula, LO is always going to be bigger because it's always a length contraction. So LO, the proper length is always going to be bigger than the contracted length, which is this is contracted when traveling at a higher speed. So that's option A. Spaceship is traveling through space with a value of this. Twice the speed. Oh, okay. We need to calculate the velocity of this one and then times it by 2. So 1 over root. Therefore, 1 over 0.04 squared. Should get 0.075 times c squared equals v squared. So then v equals 8.2 times 10 to the power 7. So then we just times it by 2 to get the velocity when it's for this velocity. So then if you plug that into the calculator, you should get 1.2, which is this one. And that's it for exam 1. Exam 2, this is power. Yep, electric power. Magnetic field goes out of the North Pole and into the South. So it goes out, and this goes into the so then it's going to be pushed this way and pulled downwards. So then if you draw a vector diagram, it's going to go like this. So the arrow should go like this. Now we have Earth's magnetic field. So when it's being pushed like this downwards, there's also Earth's magnetic field which cancels this out. So therefore it's just going to, the resultant is just going to be this. So just sideways. We have a magnetic field of this, 50 turns, and this is DC. The role of a commutator, and there's 3 marks. So what I wrote was the changes the direction the current to allow the to rotate to every half. Yeah, I think like mentioning this bit and this bit is the most, and changing the direction is the most important bit that you should have in the response. Draw an arrow on the side of JK to show the direction of the magnetic force. So use the right hand slap rule. So the current is going this way, so it's going this way. So if you use the right hand slap rule, the magnetic field is going here. Current is going this way. So therefore the force should be downwards. And you have to make sure to draw it on JK. So don't draw it here, because that would not get your mark. Current is 650 turns. The length of side JK is 5 centimeters. So force equals NIBL. Number of turns is 50 times the current is 6 times the magnetic field 0.3 times the length, which is 5 centimeters. We need to convert that to meters, which is 0.05. So then the force equals 4.5 newtons. Since this is a DC, there's not going to be both directions. It's going to go up to flow in one direction. This is missing this bit, so this is rectified, I'm pretty sure. So it has to be option A, because it flows in one direction. So I talked about how DC motors have a split ring that allows the next question. 50 turns, area is this, magnetic field is this. This is really important. If you miss this, you're not going to get the next question. The closest value to the at rotation C. So when it's at C, it's at incline at 45 degrees. So the magnetic flux equals B times A cos theta. Magnetic field is 2. Area is 0.02 times cos of 45 equals 0.04 wafers. Nope, not 0. Wait, let me check that again. 2 times 0.02 times 0.03 wafers. B. This has 50 turns from A to B, so then there's a change. So then we know that there's going to be EMF induced. So EMF equals N number of turns, change in magnetic flux over change in time, number of turns 50 times change in magnetic. From A to B. So from A to B, it's going to be 90 degrees. So we cannot use this value. If we use this value, this would be wrong. It would be really close, but so that's going to be B times A, which is equal to 0.02 times 2. So then that's over 0.15. So then induced EMF equals 13.3 volts. Constant speed, and an EMF is generated through the thing, the loop. Why is an EMF? So using the formula that there has to be a change. There always has to be a change in magnetic flux for there to be an EMF and change in time. So with that, you can have B. You can either change the area or the magnetic So what I said was according I always relate it to the formula because I find it more easy to explain. There is a change in so EMF is induced. From the left of the loop to the right. So it's going through the loop, left to right. And it's already started in there a little bit, and then it's going this way. So once there's a change in magnetic flux, the EMF is induced. So once it starts to meet at this point and goes through the loop, EMF is going to be induced. So it starts off here and it increases as it's going through because there's a big change. Then it's going to decrease as it goes through the loop and reaches its endpoint here, like when this goes through. And it's going to stay zero because it's going to be constant. There's not going to be a change in magnetic flux. But then when it leaves, there's going to be a change, but it's going to be in the opposite direction. So it's going to go downwards. Current flows around the loop in anti-clockwise direction is viewed from the left. Use Lenz's law to explain why the current flows in anti-clockwise. It's really important to know which way you're looking at it. So if you look at it from the right, it's going to be clockwise. So you need to really draw the diagram. It really helps. Oh. So, and it's moving away from the loop. It's passed through the loop and it's moving away from the loop. So it's going to go from large magnetic flux to zero. So then according to the right hand, there's going to be an induced magnetic field that goes here and here. So then according to the right hand grip, current is induced in a and then according as the magnet is moved away, the system opposes this. Creates an opposing magnetic field. This should really be 0.1, then 0.2, but yeah. Calculate the power supply to the transmission line. So VRMS voltage, primary and secondary. This is the distance. So using the power formula, P equals IV, P equals, the voltage is VRMS supplied to the transmission line. So this, we're looking at this. So it's going to be 50,000. The current is 15. So then P should equal 7.5 times 10 to the power 5 watts. So decreasing the voltage increases the current, and according to as the current increases, the power current is 15. The power loss is this. Calculate the total resistance. So we use the same formula, but we change it a little bit using this. We sub in B to P equals I squared R, so then P, which is 1,000, equals R when it's divided by 15 squared. So then R equals 40 ohms. Current in that. So as the current increases, voltage decreases. So therefore V1 over V2 equals I2 over I1. I2 is secondary and I1 is primary. So then 40 over 250. So that equals to 197.6. And there's no units for this because it cancels out. RMS. One thing to look for is if it's VP or VPP, which is peak. This is VP and this is RMS, the root mean squared. So we're looking for which one shows the correct graph. So they gave us VRMS. We're trying to find the VP, the max. So VP over root 2 equals VRMS. So then VP equals 30 root 2. And then because this is a force graph, F equals NIBL equals number of turns, just going to be 1. Current is it's just going to be 30 root 2 times which is around 0. It's 4, which is around this point here, B. So circuits A and B. This is a series parallel. So current is the same everywhere. Current will be the same in every line. Unlike this one. So using the formula V equals R, I calculated a bit differently. I calculated the total resistance, so then I could find the current. So P and the V equals IR 12. That resistance is just going to be 6 over 2, which is 3. And then plus the 3 here, which is R equals 6, R total. So 12 over 6 equals 2. I equals 2. Therefore, P equals IV. P equals 2 times 12 equals 24 watts. This is the parallel circuit. So the current is the same. So we can add up the current. So I equals 3. And then according to P equals IV, P equals 3 times 12 equals 36 watt. So therefore, circuit okay, on to this path difference wavelength is 560 S1 S2 0.32. So that's 1 2 n equals 2, and this is a node, so therefore it's going to be n minus half equals PD path difference. PD equals 2 minus half times the 560 wavelength. PD equals 840 nanometers. As the distance is now increased, describe the effective change spacing. according to increasing the length increases the diffraction. So then L is constant now. So then according decreasing, because inversely proportional, decreasing slit separation increases diffraction pattern. So I just talked about the particle model first and what would we observe. So the light two slits and should two bands. However, in many bands were formed, suggesting that was interference, which supports the wave model. Next question. The current drops because of the stopping voltage. So if you increase the stopping voltage, then there's not going to be enough energy to overcome that. So the voltage, the lowest kinetic, cannot overcome the work function the voltage is high enough to stop all electrons. Which gives a zero current. So this one we just need to plot all these points. So 4.5. I made it a bit more simple because when I drew it, I wanted whole figures. So 4.5 around here, 1.3. Five. 1.5. 6.1. 2. 6.9. 2.5, which is around here. 7.6. 7.5 here. 2, 4, 6. 8. This is the last thing here. So when I was doing it, I made sure it went through. When I used the ruler, I made sure like it went through kind of like these points, because then it would make it much more easier when we do the calculations. And we have to make sure that it goes through these points, like these points, to draw a line of best fit, like halfway through. Otherwise, you would lose marks. So h is the gradient. And we have to make sure that we use the line of best fit and not the points given. Otherwise, it'll be wrong. So I use the points 6 and 2. That's why I made it. I use this point because it's right on the line. And yeah, it would give a more accurate answer. And it had to be far apart to give a better answer. So, and then y2 minus y1. So then that would give 0 minus 2 over 2 minus 6 times 10 to the power 14, which gives 5 times 10 to the power negative 15. Yes. So when it's the longest wavelength, it's the shortest frequency, which is the threshold frequency. When it's at the threshold frequency, using this formula, the energy is 0 because there's not enough energy to overcome the work function. So then 0 equals hf minus the work function. And that's, I found that on my graph as -1, so I just use that. So then 1 equals hf. We know that f equals c over lambda. So then lambda equals hc, which is equal to 3 times 10 to the power of 8 times the value given before, which is 1.5. You get this in meters, and you need times it to get it here. So 1,500. Are there the conclusions about the nature? So recording. And then we have to relate the intensity as well. Oh. So this one, energy equals HF equals HC over E equals, this is in EV, so 4.14 times 10 to the power of negative 15 times. This is given here. And we should get EK. There's a derivation for this. EK equals H squared, whoops, H squared over lambda squared times 2m. And EK should equal, and make sure to times this by 1.6 times 10 to the power negative 19. Well, you do get 37.67, so that would be 37.7. So the electrons, this is relating to de Broglie's, have a wave like nature. So then according to P, the value same. So therefore the wavelength this is the last question, and it's at N4. So then the different energy levels you can get is from here to here. You can get from here to here. Here to here. Then here to here. Or here to here, here to here, here to here, and then this to this. So therefore, you can go from the full jump from here to here, so that's 12.8. From here to here, which is 0.7. From here to here, which is 12.8 minus. And then from here to here, so that's 12.1 minus, what does it say, 10.2, which is 1.9, and then from here to here. or you can also go from here to here as well. Yeah. The different energy levels. I think that's the last question. Yep.
Thank you, Shainon.
Thank you.
All good.